Today we are going to look at a very important molecule which formed on the surface of cosmic dust. It's called water. Just let me remind you about the atom known as oxygen, which we've seen before. An oxygen nucleus has 8 protons. It can therefore gain 8 electrons. The first 2 go into the first shell, leaving 6 electrons to go into the second shell, but this shell can hold in total 8 electrons. The oxygen outer shell has room for 2 more electrons, and as the oxygen atom is adsorbed onto a particle of cosmic dust, it could accidentally meet 2 hydrogen atoms. Their electron shells can overlap with the oxygen atom, and they therefore stick together. The 3 atoms form a single unit by the same process we've just seen of electrons being shared between the atoms. These 3 atoms then have all got closed shells and are held together by electric forces. This is called a water molecule. Notice its strange shape. It's a bit like a head with 2 ears sticking up. The shape is determined by the rules of quantum mechanics. In other words, it's part of the formation between, or the force between electrons and the nuclei of atoms. So it's a fixed shape. It's kind of L-shaped. What we've seen so far is the view from the outside of a molecule, of water molecule. But we are usually more interested in the bonds holding the atoms together. Atoms are therefore shown as coloured balls, and the bonds between them are shown as sticks, or if you're drawing a diagram you show them as lines. So hydrogen atoms are shown as white balls, oxygen as red balls. Once a molecule is formed, the electron cloud around the outside is thinner in some places than others. For example, around the hydrogen atom, the cloud is thin because the electron has been pulled onto the oxygen to fill its outer shell. So the positive charge on the protons of the hydrogen atoms shows through to the outside and can be seen by other molecules. The electron cloud around oxygen is thick because it's sharing 2 extra electrons which it's pulled in from the hydrogen atoms, and therefore it gains a negative electric charge. So when 2 water molecules meet, for example on the surface of a grain of stardust, they attract each other. The positive charge on one of the hydrogen atoms can be attracted to the negative charge on an oxygen atom in a different molecule. And this force holds them or pulls them together. It's called a hydrogen bond. It's a weak force, much weaker than the covalent bond and even weaker than the ionic bonds, but it still tries to pull the molecules together. And because of this, water molecules are sticky, and we still see the same thing today. If you get your hair wet, for example, it takes quite a long time to dry, which is much different, for example, from alcohol or spirit. If you spill any kind of spirit, it very quickly evaporates. Water doesn't, it's sticky. And if the stardust is cold, which it is, once it moves away from the star, then this hydrogen bond is relatively strong and it can hold water molecules into a rigid pattern, and this is what we call ice. So dust grains became covered in layers of ice, water ice as we see here, and there were other kinds of ice as well. And so ice is one of the major constituents of the early dust and helped, as we'll see later on, the stickiness of ice and the hydrogen bonds between the molecules helped to build planets, among other things. So, thank you for watching, and if you like this story, you might be interested in listening to it as a work of fiction. Time Crystal, it will take the characters back through time to the Big Bang. timecrystal.co.uk